In this chapter, we're focusing on digital logic, so before we get into any of the details, we should first compare and contrast analog to digital. So as you can see in the definitions on the slides here on the left, we have an analog meter, and in this case, each amplitude in a continuous range has a unique significance. On the right, I have a digital meter, and so in this case, we only have a few restricted ranges of amplitudes, and in each given range, each amplitude has the same significance. So that's maybe a little bit hard to follow, so let's look at some examples. So let's say we have a few different readings. So we have one reading which is 1.1, another reading which is 1.12, and a third reading which is 1.1453, 4. And again, apologies for that terrible penmanship. I am very inept at drawing with my mouse. But if we have these three values, what we can notice if we're talking about how they're represented on our analog meter is that they would each have a unique value. So each has a unique significance. Whereas over here for this particular digital meter, we see we only have resolution to the tenths place. So each of these would map to 1.1. So they are not different. In this case, they're reported with the same significance. And so we can actually talk about a cool math concept based on this too, is if we were to just count whole numbers, so 1, 2, 3, 4, we could go on to infinity. So it turns out between any two of these points on our analog meter, we actually have not only an infinite amount of possibilities, but an uncountably infinite number of possibilities. As you can imagine, we could say there is 1.1, 1.11, 1.111, and we could keep adding numbers as long as we like. So now let's look at how these two signals would look like graphically. So I have two plots here where we have amplitude versus time. So on the left, we have an analog signal, and in this case, we have an infinite possibility of values like we saw with those three example numbers on the previous slide. We can have any value as we're going through time on our analog signal. Now, of course, if we're talking about a specific meter, maybe there's limitations to that meter, but in theory, our analog signal can have any value on a continuous range. So in contrast, our digital value has to be at a certain level. So in this case, I've shown a digital signal with two possible levels. So it could either be up here where the laser is, or it could be down here on the axis. We could also have a digital signal with 12 different levels or 25 different levels, any number of different levels. But at any given time, we have to be at one of those different levels.